Hello students, this is Dr. Sivanagaraju from IARE. Today we are going to discuss a topic of requirements of line encoding format and various line coding formats. So this topic which comes in communication systems. So first of all, what is encoding and why did encoding and what are the types of coding? All are going to see in this session. Okay, coming to the topic, the process of converting binary data into a sequence of bits of the digital signal is known as line coding. So means converting binary data into a sequence of bits of digital signal is known as line coding. We know different types of data such as text, numbers, graphical images, audio and video. These all data are stored in computer memory in form of a sequence of bits. So first, what are the properties of line codes? No DC component. Every communication system such as a cable system does not allow the transmission of a DC signal over there. So because of that, line signal must have a zero average value. Second one is self-clocking, synchronizing capability. Symbol or bit synchronization is necessary for every digital communication system. And coming to another property, and the second one, we consider that synchronization. A sufficient amount of zero crossings must occur in the line code waveform of the receiver to be synchronization. Coming to the third property, bandwidth compression. The bandwidth of line code should be as small as possible comparatively to other codes. Coming to fourth one, differential encoding. For communication systems where the transmitted waveform occasionally experiences an inversion, differential encoding is helpful. The polarity of the encoded waveform is flipped during differential encoding without impairing the ability to identify data. Coming to another property is noise immunity. The selected line code should have a very high noise immunity. This is necessary to have a minimum number of errors introduced due to noise. Coming to this property, the noise is always additive. So that's why we can call it as additive white Gaussian noise. Whenever the signal is in angular form, the noise adds is very easily. When the signal is in digital form, noise immunity is going to less. So when you see this picture, so this is an analog signal. So the noise adds easily, then its signal is going to very corrected easily. When you consider a digital signal like this one, so here the noise adds like this. So when you shaping or cleaning this pulse easily, then this analog signal. Okay, so that's why we preferred this line coding. And another one is minimum crosstalk. The crosstalk should be minimized, which is transmitted present between adjacent channels. Because of this line coding or the properties of line coding, crosstalk is going to minimum. Why? Because when the signal is in analog form, again, the overlapping is easily. For example, this you can call as overlapping. Okay. So to this overlapping, you can get a crosstalk. The sixth property is minimum crosstalk. Now we come into the various line encoding formats. In the first part, we discussed what is line coding and what are the properties. Now, various line encoding formats. So by this technique, we convert a sequence of bits to a digital signal. At the sender side, digital data are encoded into a digital signal. And at the receiver side, the digital data are decoded by decoding the digital signal. So, here, what are the different types of line coding techniques? So, here we can roughly divide line encoding schemes into 5 categories. First one is unipolar. Second one is polar. Third one is bipolar. Fourth one is multi-level. And fifth one is multi-transition. So these are the different types of line coding schemes. And in this session, we are going to briefly discuss NRZ, RZ, biphase, bipolar schemes. Okay. Coming to unipolar. In this scheme, all the signal levels are either above or below the axis. So in this unipolar, taken NRZ as an example, non-return to zero. It is a unipolar line coding scheme in which positive voltage defines bit 1 and the zero voltage defines bit 0. Signal does not return to zero at the middle of the bit. Thus, it is called NRZ, non-return to zero. It never comes to the zero. So, here you can see 1, 0, 0 like this. So, this is the data we are going to represent. And another one is polar. Polar schemes. In polar scheme, the voltages are on the both sides of the axis. NRZ L and NRZ I. So these are somewhat similar to unipolar NR scheme. But here we use 2 levels of amplitudes. So that means positive and negative voltage levels. So NRZ L, that is NRZ level. I means invert. So in NRZ level, the level of the voltage determines the value of the bit. Typically, binary 1 maps to a logic level high and a 0 maps to logic level low. And for NRZI, it is invert. 2 level signals has transition at a boundary. If the next bit that are going to transmit is a logical one and does not have a transition if the next bit that we are going to transmit is a logical 0. So see this waveform. So one is level and one is inverter. Non-return to 0 levels. So in this first one, taken as 2 levels of voltages, positive and negative. And in second one, the inversion will occur for zeros. Okay. And another one is return to 0. So return to 0 is another form of scheme. So that is a solution to the NRZ problem, which uses 3 values: positive, negative, and 0. That means positive like this. This is 0 level like this. Positive, negative and 0 level. Okay. And another one is biphase Manchester and differential Manchester. In Manchester, encoding is somewhat combination of the RZ and NRZL, that means not returned to 0 level schemes. The duration of the bit is divided into two halves. The voltage remains at one level during the first half and moves to the other level in the second half. The transition at the middle of the bit provides synchronization. So that means here, for example, this is we consider as a period of a full pulse in NRZ or Z, but here we consider as half bit like this, half bit. Okay. So voltage remains at one level during the first half and moving to the other level to the second half. And another one is a differential Manchester, is somewhat combination of the RZ and NRZI schemes. It is always a transition at the middle of the bit, but the bit values are determined at the beginning of the bit. If the next bit is 0, there is a transition. If the next bit is 1, there is no transition. So this is differential Manchester encoding. So you can see. So half bit to be considered, half bit duration, are considering the full width of the time. So one is Manchester and another is differential. So here a non-inversion and inversion is shown. Okay. And another is a bipolar schemes. So in this scheme, there are three voltage levels, positive, negative and 0. The voltage level of one dead element is at 0, while the voltage level of other element alternates between positive and negative. So we can call it as AMI, alternate mark inversion. A neutral 0 voltage represents binary 0 and binary 1s are represented by alternating positive and negative voltages. So here one have two voltages where 0 is simply 0 voltage. That means, for example, 1, 0, 1. So these are the periods, time period of this one. So here I taken positive. So this is a positive voltage for 1 and 0. There is no voltage. And coming to another one, I take negative voltage. So this is my negative voltage. So alternate mark inversion. So binary ones are represented by alternating positive and negative voltages. And another is pseudo ternary. So bit 1 is encoded as a 0 voltage and the bit 0 is encoded as alternating positive and negative voltages. So it is opposite of AMI. So this is inversion of AMI, you can call as pseudo ternary. So this comes under bipolar schemes. So here you can see AMI, alternate mark inversion, another is pseudo ternary. So this is vice versa. Clearly reverse. So 0 having two voltages, whereas in AMI you taken 1 have two voltages. There is a positive taken as one time and another one taken as negative voltage, and 0 as 0. Whereas in pseudo-ternary, which is opposite to AMI, here one marked as 0 voltage. You can see one is 0, 0. So this one is 0 and this one is 0. And here the first 0 taken as a positive voltage, and coming to the another 0 negative, and again positive, and again negative. So this is inversion version of AMI. Now, what are the advantages and disadvantages of unipolar line coding scheme? Why? Because we discussed unipolar, polar, bipolar. So, what are the advantages and disadvantages of this unipolar? First one, simple receiver circuit. And another one is low DC component. Third one is low cost. So, these are the advantages of unipolar. Coming to the disadvantage, poor noise immunity, and another disadvantage is limited dynamic range. Why? Because it's limited dynamic range. The unipolar line coding scheme has a limited dynamic range as it only uses a positive voltage levels. It uses only positive voltage levels. So this is the disadvantage for unipolar. Coming to the polar, advantage and disadvantage of polar. For first advantage of polar is high noise immunity. High noise immunity. And second one is error resistance. Why? Because it uses differential signal. So that's why noise is going to more immunity, and at the same time error resistance also. It means less susceptible to errors. And disadvantage of this scheme is complex receiver circuit. The receiver circuit is very, very complex. Okay. And another one is limited data rate. Okay. So this is another disadvantage. Coming to advantage and disadvantage of bipolar. The first advantage of bipolar is high data rate. That means the bipolar line coding scheme has a high data rate. It uses positive and negative voltage levels to represent the digital signal. So it uses two levels, positive and negative voltage levels. So it requires more data. Another one is differential signal. The bipolar line coding scheme uses a differential signal which improves noise immunity and error resistance. And here also the disadvantage similar to the both of the previous one. Complex receiver circuit, limited dynamic range. And applications. So what are the applications of this codes? NRZ encoding is used in RS-232 based protocols, and Manchester encoding is used for Ethernet networks. In differential Manchester encoding, token ring networks. Coming to NRZ inverted encoding, fiber distributed data interface. So this all data is taken from for Greeks and Internet and Simon Hawking book. So this information is given for understanding the communication system subject. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.